morning, Mahaganadhipati. Good morning. Vaishnavi and Sohail, you take the attendance. Good morning. Yes. So those who attended and was there till end, give them 5 marks. Those who attended sharply and with us till end of the session, give them 5 marks. And those who attended and immediately left, 0. Those attended and left in the half, 2.5. Those who attended and be there with us up to 75% of the class, give them 3.5. So maintain a record like this. Is that understood? Every month I'll ask the record. Every month I'll ask the record and I'll put the signature. Actually I had to do this one last year only, but it was not done. Once again, those who attended the class and there with us, total class, for them full marks, 5 marks. Those who attended and immediately left, 0. Those who attended and were there at us for some time, for 15 minutes, 10 minutes like that, give them 1 mark or 1.5. Half of the meeting was there and half not there, 2.5. 3/4 of the meeting was there, 3.5. And full 5. Ten minutes, 15 minutes, even 10 minutes, 15 minutes also no need to give any marks. Only half should be counted. Maybe internet issues, they are attended for only half time. Because of internet issues they left. We can give 2.5 for them. That's all. That too we need to ask them. Okay? Okay. Right? Good morning to everyone. And I started probability. I gave some examples yesterday in the class. And there are some words related to probability that was there on the board, you can see. These words are very, very important. First, if you understand the meaning of these words, then the probability becomes easy for you. And its weightage in the board exams is 6 marks. Probability weightage in board exams is 6 marks now. So easy topic. And that means you are going to get 6 marks easily. Note down the names, everyone. Not everyone. Vaishnavi as well as Sohaili. Right. First, random experiment. So I already told you, probability is a tool. It is a tool like screwdriver, like computer, like softwares. It is a tool which is used to solve a problem. Okay. Tool is that which is used to solve our problem, either physically or theoretically. So it is a tool which is used to measure the uncertainty. I told you yesterday. Probability is a tool which is used to measure uncertainty. Uncertain situations ఎక్కడైతే ఉన్నాయో, ఎక్కడైతే మనకి అరైజ్ అయినాయో అక్కడ ఈ ప్రాబబిలిటీ అనేది మనకి it is used to measure the uncertainty. Okay na? So random experiment, this one you have to know properly. What is random experiment? I think everyone know what is an experiment. What is an experiment? Experiment is that one that we perform for getting some outcomes. Is that right? For example, preparation of oxygen. Chemistry lo untundi kada, preparation of oxygen is an experiment. So in that experiment we are going to prepare oxygen or nitrogen. Evo untai chemistry experiments. That means in the beginning of the experiment only we are able to say what is the outcome. Okay na? In the beginning of the experiment only we are able to say what is the outcome. But what is the random experiment then? What is the difference between an experiment and a random experiment? Random experiment is an experiment where we cannot say the outcome before until the experiment is completed. Understand? It is an experiment where the outcomes cannot be we cannot say the outcome before it was completed. Means we can say the outcome after completed only. But we can predict the possibilities of the outcome. Such an experiments are called random experiments. Then clearly I will tell you with the help of an example. See, rolling a die is an experiment. Rolling a die is an experiment. But suppose a die is rolled. Can anyone say what is the outcome before doing the experiment? A die is rolled. A die is rolled. Suppose Bhargav Harsha rolled a die. Can anyone say the outcome before rolling the die? Or tossing a coin is an experiment. Can anyone say that surely head will come or surely tail will come? No. So when we can say after completion of the if the experiment is completed, then only we can say the outcome. Such experiments are called random experiments. But there is a clause over here, we can predict the outcomes. No, we can say the possibilities of the outcome. Once again, the outcome of an experiment cannot be predicted in advance. Such experiments are called random experiments. Example, rolling a die, tossing a coin. But we can say the possibilities. We can say the possibilities. Example, tossing a coin. What is the outcome? We don't know. We need to complete the experiment. We don't know. We cannot say that head will come or tail will come. But there are two chances, only two chances, either head or tail. These are the possibilities. Okay, rolling a die. Rolling a die is an experiment. Okay? Can we predict the outcome? Can anyone predict the outcome? No. We cannot predict the outcome. But we can say the possibilities. We cannot predict the outcome, but we can say the possibilities. What are the possibilities? 1 routes, 2 routes, 3 routes, 4 routes, 5 routes, 6 routes. The R routes. Anyone out of all these 6. Then what we call 1, 2, 3, 4, 5, 6? They are called possible outcomes. They are called possible outcomes. Okay? But we cannot say this was the outcome exactly when a die is rolled. Such experiments are called random experiments. I think everyone understood random experiments. Any doubts in that? The outcome of an experiment cannot be predicted in advance, but we can say the possibilities of the outcome. Such experiments are called random experiments. Now, what is your doubt, Vanshika? Vanshika, what is your doubt? I gave some examples. 2 examples I gave. If you want, I can give you one more example. Means you have a bag. You have a bag. In that bag, red, blue, green balls are there. Red, green, blue balls are there. Total 3 colors. Okay. The bag was closed. And I asked you to take one ball without looking into the bag. I asked you to take one ball from the bag without looking into the bag. Can you say that you are taking out a green ball before taking it out? Once again I am explaining. Once again. Vanshika is having a bag which contains balls of colors red, blue, green. And I asked Vanshika to take out one ball from the bag without looking into the bag. Now, can Vanshika says that she is going to take green ball out before completing the experiment? No. So that's why it is called a random experiment. But we can say, sir, she may take red ball, she may take blue ball, she may take green ball. If green balls are more, probability of taking green balls is more. If blue balls are very less, probability of taking blue balls are very less. That we can say the possibilities, but we cannot say the exact outcome until the experiment is completed. Did you understand? Now, second one, event. Event is nothing but an outcome. Event is an outcome for which we are calculating the probability. Event is an outcome for which we are calculating the probability. For example, a die is rolling. A die is rolled. Okay? And I want to find out the probability of getting an even number. So, here, getting an even number is called an event, which is also an outcome of the experiment. Okay, na? So, event is an outcome for which we are calculating the probability. Okay, na? Outcomes may be many in an experiment. In an experiment, outcomes may be many. But for some only we are calculating, for some outcomes only we are calculating the probability. So all those outcomes are called events. Okay na? Next, equally likely events. Equally likely events. Okay na? Yeah. Two or more events which are having same probability are called equally likely events in an experiment. In an experiment, if two or more events are having same probability, they are called equally likely outcomes. For example, tossing a coin. Tossing a coin. Probability of getting head. Probability of getting head 1/2. Means what is 1/2? What is 1 and what is 2? I'll explain that. Probability of getting tail, that is also 1/2. So here the event probability of getting head and the probability of getting tail, both the events are having same probability. Two events, getting head, getting tail, both are having same probability. That's why they are called equally likely events. Equally likely events. Okay na? One more example. A die is rolled. ఇందుకు డై అండ్ కాయిన్స్ చెప్తానంటే మీకు కాన్సెప్ట్ ఎక్కువ అర్థం అవుతుంది. A die is rolled. Yeah. What are the possible outcomes? A die is rolled. A die is rolled. We cannot say the exact outcome, but we can say the possibilities. Is that right? 1, 2, 3, 4, 5, 6 are the possible outcomes. 1, 2, 3, 4, 5, 6 are the possible outcomes. Okay. Now, what is the probability of getting 1? Probability of getting 1, 1/6. Getting 2, 1/6. Getting 3, 1/6. Getting 4, 1/6. Getting 5, 1/6. Getting 6, 1/6. So all these 6 events, we can call them as equally likely events because their probabilities are same. Because their probabilities are same. Okay na? So they are called equally likely. Now, less likely events. Less likely events. Yeah. I think many of you know the basketball ground. Is that right? In our school, basketball ground. Now Yuvraj is standing near the basket and Aniket is standing far away from the basket. Now both are having basketballs in their hands. Now who is having more chances of throwing ball into the basket? Yuvraj. And what about Aniket? What about Aniket? Equal chances. Meghana. Both are having equal chances. Okay, equal chances, but Yuvraj is standing near the basket and Aniket is standing far away from the basket. Now who is having more chances? You cannot say equal chances. More chance is for Yuvraj and less chance for Aniket because he is away from the basket. Is that right? In the same way. Now, Right. Now Sunita, who is Aniket. Aniket is having a bike. He is having a bike. Winter time, it is winter time in the month of December or January. You want to ride the bike in the morning. Now the self was under what we call it as maintenance, means it is not working. Now he has to kick the bike. Now he is having less chances of starting the bike with one kick or more chances. Winter time. బాగా చలికాలంగా ఉంది. బాగా వాడు బైక్ తోలుదాం అనుకున్నాడు. ఈజ్ వాంట్ టు రైడ్ ద బైక్. సెల్ఫ్ వాజ్ అండర్ రిపేర్. నౌ హీ హ్యాస్ టు కిక్ ద బైక్. It is winter season, the month of January, early morning. Now he has to kick the bike. So he is having less chances or more chances of starting bike in one kick. Yes, less chances. Now if the season is summer, if it is summer season, more chances. Very good. Okay, na? Right. Next one is shore event. An event of an experiment whose probability is exactly 1 is called shore event. An event in an experiment whose probability is exactly 1 is called shore event. Can anyone say one example? One example. Yeah, I'll tell you. A bag contains only red balls. Okay, na? Now, Bashita want to take out one ball from the bag. What is the probability of getting one red ball? Bashita wants to take one ball from the bag. What is the ball? What was the probability that the ball taken out was a red ball? 1. Because the bag contains only red balls. So the probability of getting red ball is, suppose if the bag contains 10 red balls, probability of getting one red ball is 10 by 10. Probability of getting red ball 10 out of 10, 1. Okay. If a die is rolled, what is the probability of getting a number less than 7? If a die is rolled, what is the probability of getting a number which is less than 7? Six by 6, 1. Very good. So shore events whose probability is 1, they are called shore events. Now, impossible events means whose probability is 0. Such events are called impossible events. Can anyone give one example? Yeah, very good, Aniket. Very good. Getting a number 7 when a die is rolled. Impossible event. Tanush, me failing exam. Impossible. Very good, Tanush. Very good. Sun rising in the west. Very good. Very good. Evadu Tanmay. Good. Getting a red ball in a bag full of green balls. Excellent. Excellent. Impossible events. Good, good. Next. Complementary events. Complementary events. See, two events are two outcomes of an experiment. If one happens, the other one doesn't happen. Such experiments, such outcomes are called complementary events. For example, when a die is rolled, what is the probability of getting one? 1 by 6. Not getting one? 5 by 6. Okay, na? Probability of getting one is 1 by 6 and not getting one is 1 by 6. Is 5 by 6. Now what is the sum of possibilities? Sum of probabilities? 1 by 6 plus 5 by 6 is 1. Okay, na? So if the probability of two events in an experiment, two or more events, is 1, not 2 or more, only 2, sorry, not 2 or more, only 2 events. The probability of any 2 events in an experiment, if their sum is 1, they are called complementary events. Example, probability of getting 1 and probability of getting greater than 1. When a die is rolled, probability of getting 1 is 1 by 6 and probability of getting greater than 1 is 5 by 6. Experiment is rolling a die. 2 events are there with me. One event is probability of getting 1. The other event is probability of getting greater than 1. So first event probability 1 by 6, second event probability 5 by 6. What is their sum? By 6, which is 1. 6 by 6, which is 1. So they are called complementary events. When a coin is tossed, probability of getting head, 1 by 2. Probability of getting tail, 1 by 2. What is their sum? 1. So they are called complementary events. Okay, na? Yeah. Yeah. These are the two words are two what we call words, only two concepts left. One is possible outcomes, favorable outcomes. Now think about possible outcomes. An experiment, suppose see, possible outcomes depends upon the experiment. For example, what are the experiments we have? Rolling a die, tossing 1 coin, tossing 2 coins, tossing 3 coins, rolling 1 die, rolling 2 die, and playing cards, and some other miscellaneous experiments. All these are experiments. According to the experiment, we can write the possible outcomes. And favorable outcomes means in an experiment, out of possible outcomes, according to our event, we can write the favorable outcomes. I'll give you an example. Okay. Rolling a die. Possible outcomes. 1, 2, 3, 4, 5, 6. Favorable outcomes. It depends upon the event. My event is getting an even number. Favorable outcome depends upon the event. Now my event is getting an even number. So the favorable outcomes are 2, 4, 6. These are possible outcomes and these are favorable outcomes. Okay. Now probability of getting an even number is equal to number of favorable outcomes by total number of possible outcomes. That is, number of favorable outcomes is 3, total number of possible outcomes is 6, 1 by 2. Okay, na? This is how we have to calculate the probability. First we need to write the possible outcomes of the experiment. Then according to the event we need to write favorable outcomes. According to the event we need to write favorable outcomes. Then the formula, probability of getting even number is equal to number of favorable outcomes ante 3 and the total number of possible outcomes ante 6. 3 by 6, 1 by 2. This is how you have to do your classwork. For every event you have to calculate the probability like this. Note it down, children. Your classwork must be like this. Possible outcomes 1, 2, 3, 4, 5, 6. Favorable outcomes. In the favorable outcomes, you have to write the event, getting an even number. Like that. Note down this. Okay. Can I wipe the board? Okay. Children, I am going to write possible outcomes for coin problems. For coin problems, I am going to write the possible outcomes. Note it down, okay? one coin, two coins, three coins. For one coin, possible outcomes are head or tail. Only two. Only two possible outcomes you'll have. When you toss one coin, means one coin experiment. Now, two coins, both heads, first one head, second one tail, tail on first one's, head on second one, and on both the coins, tail, tail. Four possible outcomes. Remember, tossing two coins at a time is the same as tossing a coin two times. Tossing two coins at a time is same as tossing a coin two times. Possible outcomes is 4. Number of possible outcomes is 4. Okay, na? 3 coins. Head on all the 3 coins. Head on all the 3 coins. First 2 coins head, third coin tail. Head on first, head on last, middle coin tail. On first coin tail, remaining 2 coins head. In the same way, tail, tail, head. Tail, head, tail. Head, tail, tail. And tail on all the 3 coins. So total 8 possibilities. Total 8 possibilities. So if we tossing a coin experiment, if it is one coin we have only 2 possibilities. If it is 2 coins we have 4 possibilities. If it is 3 coins we have 8 possibilities. Okay, na? So according to the experiment and according to the event, you have to give the answer properly. Okay? Note down the possibilities. According to the event, you have to give what are possible outcomes and what are favorable outcomes. Then probability of getting an event is equal to number of favorable outcomes by total number of possible outcomes. Next, a die. Experiment is rolling a die. 1, 2 dice. 1 die, 2 dice. The possible outcomes for rolling a die is 1, 2, 3, 4, 5, 6. Total 6 possible outcomes. Yeah. Possible outcomes 6. Okay. One on first day, But 2 on second die, we make it like that, na? Am I audible now? Yeah. 1 on first die, 1 on second die. And 1 on first die, 2 on second die. We make it like that, na? Yeah. 1 on first die, 3 on second. 1 on first die, 4 on second. 1 comma 5, 1 comma 6. I think we make it like that. Is that right? Now, some of you told that we can get 12 outcomes. Now Tanush is saying 24 outcomes. Which is right, 12 or 24? I will try to write one some more. 2 on first die, 1 on second die. 2 on first die, 1 on second die. 2 comma 2. Okay? 2 on first die, 3 on second die. 2 on first die, 4 on second die. 2 5, 2 6. 3 1, 3 2, 3 3, 3 4, 3 5, 3 6. 4 1, 4 2, 4 3, 4 4, 4 5, 4 6. 5 on first die, 1 on second die. 5 2, 5 3, 5 4, 5 5, 5 6. 6 on first die, 1 on second die. 6 on first die, 2 on second die. 6 on third die, 6 on first die, 3 on second die. 6 4. 6 on first die, 5 on second die. 6 on first die, 6 on second die. Total how many are there? 36. So 36 possible outcomes will be there when 2 dice are rolled at a time. 36 possible outcomes. When 1 die is rolled, only 6 possible outcomes. When 2 dice are rolled, we get 36 possible outcomes. Okay, na? Now, so according to the possible outcomes, according to the events, you have to give the answers. Okay? But every time you have to write probability of getting an event is equal to number of possible favorable outcomes by total number of possible outcomes. That is sure for now. Now, playing cards. Playing cards. A deck contains 52 cards. A deck contains 52 cards. Okay? And out of those 52 cards, we'll have 2 colors. Out of those 52 cards, we have 2 colors, red and black. Red and black colors. Okay? Now, and the 52 cards having in two colors, red and black. In red, we will have two shades. In red, we have two shades. Okay? Two shades. This shape is called hearts. The shape in the red color, this one we can call it as hearts. Okay? And this shape we can call it as diamonds. Diamond. Okay, children? So, out of 52 cards, we have two colors, means 20 red and black, 26 in red color, 26 in black color. In red color, again two shapes will be there. One is hearts, the other one is diamonds. Okay? And again, black color will have two shapes. One is called clubs. This shape we can call it as clubs. Okay, now clubs. And this one we can call it as spades. This is spades. So, out of 52 cards, we have two colors and four shapes. We have two colors and four shapes. Okay? So this is clubs, spades, hearts, diamonds. Okay, na? Now, give me some time. Yes. Give me one. Just I am arranging the cards in order. Yeah. Give me 1 minute. So each shape contains 13 cards like this. Each shape contains 13 cards like this. You can observe 13 cards. In those 13 cards, this is what we call, this is ace. This one is ace. Okay, ace. And there are number cards from 2 to 10. one A is there, which is called A's, and there are numbers from 2 to 10. From 2 to 10. You can observe some numbers over here from 2 to 10. 2 to 10. Okay? And there are 3 cards which are in the name of JQK. Jack, Queen, King. Jack, Queen, King. Okay? Na? So, in each shape, we will have 13 cards. 1 A, which is called Ace. 1 King, 1 Queen, and 1 Jack, and the remaining cards are number cards, and the number starting from 2 to 10. It starts from 2 and ends with 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So each shape contains 13 cards. Each shape contains 13 cards. 1 ace, 9 number cards, and 1 queen, 1 king, and 1 jack. Is that understood, children? Okay, na? King, queen, jack. King, queen, jack. These are called face cards. These 3 are called face cards. King, Queen, Jack, these 3 are called face cards. And A is called Ace. The card A is called Ace. And 2, 3, 4, 5, 6, 7, 8, 9, 10. These are called number cards. So we have these cards 3, and this is 1, and this is 9. Total 13 cards. Total 13 cards. So each shape contains 13 cards. Okay, na? Now, can anyone say in a deck of cards how many face cards will be there? In a deck, how many face cards will be there? How many face cards? In one shape, 3 face cards. Total 4 shapes. 4 3s, 12 face cards. We can see 12 face cards. Is that right, children? Now, how many number cards will be there? How many number cards? अरे वन शेप లో ఎన్ని నెంబర్ కార్డ్స్ ఉంటాయి తనుష్? వన్ షేప్ లో ఎన్ని నెంబర్ కార్డ్స్ ఉంటాయి? In one shape we can see 9 number cards. So 4 shapes total. 4 into 9, 36 number cards. And how many face cards? How many face cards? Suppose in a deck of 52 cards, if a card is drawn at random, what is the probability of getting a face card? What is the probability of getting a face card? Is an event. What are favorable outcomes? How many favorable outcomes will be there? How many favorable outcomes will be there? What is my question, Vaishnavi? In a deck of 52 cards, What is the probability of getting a face card? For this event, how many favorable outcomes are there? 12. And what is the total number of possible outcomes? Total number of possible outcomes. Yes, favorable outcomes 12. Possible outcomes 52. Very good. Then what is the probability of getting a face card? Probability of getting a face card. 12 by 52. Very good. 4 3s are 4 13s are 3 by 13. 3 by 13. Probability is 3 by 13, not 12 by 52. It is not 12 by 52, it is 3 by 13. Okay, na? So, any doubts till now? Any doubts? Okay. Vaishnavi, take the attendance. And Soheli, you also take the attendance. Complete the exercise, children, and submit the notes after reopening. But you have to prepare this chapter na, solve the problems in the exercise. It can be easily solved because you know all the syllabus na, coins, dice and playing cards, and some miscellaneous problems also will be there like balls in a bag, atla untayi leda spinning wheel ani atla untayi, avani easy nevi. So I told you na, according to that give the marks for attendance as well as give the marks and show it to me on Monday, tomorrow. Yes, you have to write. Yes, after vacation only. Yes, even that one also after vacation. So 4 chapters are done. All these 4 chapters you have to submit on after vacation, reopening day let it be. But attendance and the marks you have to show me, Vaishnavi and Soheli, tomorrow for this online session. Dhanyavad, you can leave the class. No doubts, na? You are not clicking on like. Everyone click on the like button and leave. Children, click on the like button. Then leave the class. Yeah, you have to prepare RS Agarwal also. Arey, only 13 likes. Click on the like button and if possible share this video to your friends. Good. Only 19 likes. Okay. Bye. Yeah, you have to prepare RS Agarwal. Bye.